The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment installation in the United States. It is updated every 3 years to reflect advancements in technology, address emerging safety concerns, and improve the overall safety of electrical systems. One of the key areas of focus in the NEC is ground fault circuit interrupter, or GFCI, protection. GFCIs are designed to protect people from electrical shock by monitoring the current flowing in a circuit. If there is an imbalance between the outgoing and returning current, indicating a potential ground fault, the GFCI will quickly trip the circuit, cutting off the power and preventing a dangerous shock. Over the years, the NEC has expanded the requirements for GFCI protection to include more and more locations, recognizing the importance of this technology in preventing electrical injuries. Before delving into the specific year when garage receptacles were required to have GFCI protection, it is helpful to understand the evolution of GFCI requirements in the NEC. The initial focus was on areas where there was a high risk of electrical shock due to the presence of water, such as bathrooms and outdoor locations. As the technology improved and became more affordable, the NEC expanded the requirements to include other areas where people might be exposed to electrical hazards. The requirement for GFCI protection in garages is a significant safety measure. Garages often have concrete floors, which can increase the risk of electrical shock if a person comes into contact with a live wire or faulty equipment. Additionally, garages are often used for a variety of tasks, some of which may involve the use of power tools or other electrical equipment. The 2005 edition of the National Electrical Code mandated that all 125-volt, 15 and 20 amp receptacles in garages must have GFCI protection. This requirement applies to all receptacles, not just those located near sinks or other wet areas. This change was made to provide a greater level of safety in garages where the risk of electrical shock is elevated. The specific section in the 2005 NEC that addresses GFCI protection for garage receptacles is 210.8 A2. This section states that all 125-volt, 15 and 20 amp receptacles installed in garages must have GFCI protection. This requirement applies to all garages, regardless of whether they are attached to a dwelling unit or are detached structures. It is important to note that this requirement applies to all receptacles, not just those that are readily accessible. Even receptacles that are located behind appliances or other obstructions must have GFCI protection. The reason for this is to ensure that all receptacles in the garage are protected, regardless of their location or accessibility. The GFCI protection can be provided by a GFCI receptacle or a GFCI circuit breaker. A GFCI receptacle is a special type of receptacle that has a built-in GFCI device. A GFCI circuit breaker is a circuit breaker that provides GFCI protection for the entire circuit. Both options are acceptable, but it is important to choose the option that is most appropriate for the specific installation. When installing GFCI protection for garage receptacles, it is important to follow all applicable codes and standards. This includes using the correct wiring methods, properly grounding the receptacles, and testing the GFCI protection to ensure that it is working properly. It is also important to note that GFCI protection is not a substitute for proper wiring and grounding. GFCI protection is designed to protect people from electrical shock, but it will not prevent the fire or other electrical hazard. It is essential to ensure that all electrical wiring and equipment is installed and maintained in accordance with all applicable codes and standards. In summary, the 2005 edition of the National Electrical Code required that all 125-volt, 15 and 20 amp receptacles in garages must have GFCI protection. This requirement is intended to provide a greater level of safety in garages where the risk of electrical shock is elevated. When installing GFCI protection for garage receptacles, it's important to follow all applicable codes and standards. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. The NEC is a living document, meaning it is updated regularly. It is essential to stay informed about the latest changes to the code to ensure that your electrical installations are safe and compliant. The NEC is not law, but it is widely adopted by state and local jurisdictions. Many jurisdictions incorporate the NEC into their building codes, making it legally binding. Even in jurisdictions where the NEC is not legally binding, it is still considered a best practice to follow its recommendations. The NEC is developed by the National Fire Protection Association, or NFPA. The NFPA is a non-profit organization that develops codes and standards for a wide range of hazards, including fire, electrical, and life safety. The NEC is developed by a committee of experts from various fields, including electrical engineers, contractors, inspectors, and manufacturers. The committee meets regularly to review and update the code. The NEC is a consensus-based document, meaning that all changes to the code must be approved by a majority of the committee members. This process ensures that the NEC is based on the best available knowledge and reflects the needs of all stakeholders. The NEC is divided into several chapters, each of which covers a specific topic. Chapter 1 covers general requirements, such as definitions, wiring methods, and grounding. Chapter 2 covers wiring and protection, including overcurrent protection, grounding, and GFCI protection. Chapter 3 covers wiring methods and materials, including conduit, cable, and wire. Chapter 4 covers equipment for general use, including appliances, lighting, and motors. Chapter 5 covers special occupancies, such as hazardous locations, healthcare facilities, and marinas. Chapter 6 covers special equipment, such as electric signs, elevators, and fire alarm systems. Chapter 7 covers special conditions, such as emergency systems, standby power systems, and critical operations power systems. Chapter 8 covers communications systems, such as telephone, data, and cable television systems. Chapter 9 contains tables and examples to help users understand and apply the NEC. The NEC is a complex document, but it is essential for anyone who works with electrical systems to have a thorough understanding of its requirements. By following the NEC, you can help ensure that your electrical installations are safe and compliant. GFCI protection works by monitoring the current flowing in a circuit. In a normal circuit, the current flowing to the load is equal to the current returning from the load. However, if there is a ground fault, some of the current will flow to ground through a path other than the intended return path. This can happen if a person comes into contact with a live wire or if there is a fault in the wiring or equipment. A GFCI device detects this imbalance in current and quickly trips the circuit, cutting off the power and preventing a dangerous shock. GFCI devices are very sensitive and can detect even small imbalances in current. They are typically designed to trip when the current imbalance exceeds 5 milliamps. This is a very small amount of current, but it is enough to cause a dangerous shock. GFCI devices are available in two main types: GFCI receptacles and GFCI circuit breakers. GFCI receptacles are designed to replace standard receptacles and provide GFCI protection at the point of use. They are typically used in bathrooms, kitchens, and other areas where there is a high risk of electrical shock. GFCI circuit breakers are designed to replace standard circuit breakers in the electrical panel. They provide GFCI protection for the entire circuit. They are typically used for circuits that serve multiple receptacles or for circuits that serve equipment that is located in a wet or damp location. When installing GFCI protection, it is important to follow the manufacturer's instructions carefully. It is also important to test the GFCI protection after it is installed to ensure that it is working properly. GFCI receptacles typically have a test button that can be used to test the GFCI protection. When the test button is pressed, the GFCI should trip and cut off the power to the receptacle. GFCI circuit breakers typically have a test button that can be used to test the GFCI protection. When the test button is pressed, the GFCI should trip and cut off the power to the entire circuit. If the GFCI does not trip when the test button is pressed, it is important to have it inspected by a qualified electrician. GFCI protection is a valuable safety feature that can help protect people from electrical shock. By understanding how GFCI protection works and by following NEC requirements, you can help ensure that your electrical installations are safe and compliant. The 2005 NEC was a significant update to the National Electrical Code, introducing several important changes to improve electrical safety. In addition to the GFCI requirements for garage receptacles, the 2005 NEC also included changes related to arc fault circuit interrupter, or GFCI, protection, surge protection, and other areas. GFCIs are designed to protect against fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when there is a break in the insulation of a wire or when there is a loose connection. Arc faults can generate a lot of heat, which can ignite nearby combustible materials and cause a fire. The 2005 NEC expanded the requirements for GFCI protection to include more areas of the home, such as bedrooms and living rooms. This change was made to provide a greater level of protection against electrical fires. Surge protection is designed to protect electrical equipment from damage caused by voltage surges. Voltage surges are sudden increases in voltage that can occur due to lightning strikes, power outages, or other events. Voltage surges can damage sensitive electronic equipment such as computers, televisions, and appliances. The 2005 NEC introduced new requirements for surge protection in certain types of buildings, such as hospitals and data centers. This change was made to protect critical equipment from damage caused by voltage surges. The 2005 NEC also included changes related to grounding, bonding, and other areas of electrical safety. These changes were made to improve the overall safety of electrical systems and to reduce the risk of electrical shock and fire. The NEC is a constantly evolving document, and it is important to stay informed about the latest changes to the code. By following the NEC, you can help ensure that your electrical installations are safe and compliant. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. They can help you understand the NEC requirements and ensure that your electrical installations are safe and compliant. Furthermore, proper grounding and bonding techniques are crucial for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device such as a circuit breaker or fuse to trip and clear the fault. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current to flow. This helps to minimize the risk of electrical shock and fire. The NEC contains detailed requirements for grounding and bonding, and it is essential to follow these requirements carefully. The proper grounding or bonding can create a dangerous electrical hazard. In addition to the specific requirements for GFCI protection in garages, the NEC also includes general requirements for GFCI protection in other locations. For example, the NEC requires GFCI protection for all receptacles located within 6 feet of a sink or water source. This requirement applies to both residential and commercial occupancies. The NEC also requires GFCI protection for all outdoor receptacles. This requirement is intended to protect people from electrical shock when using electrical equipment outdoors. The NEC also includes requirements for GFCI protection in bathrooms, kitchens, and other areas where there is a high risk of electrical shock. These requirements are constantly evolving as new technologies and safety concerns emerge. It is important to stay informed about the latest changes to the NEC to ensure that your electrical installations are safe and compliant. Moreover, electrical safety is not just about following the NEC requirements. It is also about using common sense and being aware of potential hazards. Never work on electrical equipment unless you are qualified and trained to do so. Always turn off the power before working on any electrical equipment. Use caution when working around water, as water can conduct electricity and create a dangerous shock hazard. Inspect electrical cords and equipment regularly for damage. Replace any damaged cords or equipment immediately. Do not overload electrical circuits. Overloading a circuit can cause the wires to overheat and start a fire. Use the correct size and type of fuses and circuit breakers. Using the wrong size or type of fuse or circuit breaker can create a dangerous electrical hazard. Be aware of the location of your electrical panel and know how to turn off the power in case of an emergency. By following these simple safety tips, you can help protect yourself and others from electrical hazards.